In the previous video, we found that if f of x equals 2x minus x squared, then f prime of x is equal to 2 minus 2x. And remember what the derivative tells us. The derivative gives us a formula for the slope of this curve at any value of x. Now you may recognize this as a quadratic function. I hope you do. And that tells us that its graph is going to be a parabola, and it's actually going to be a parabola that opens down, and so it looks kind of like this. And what we call the vertex of the parabola occurs at x equals 1. If you graph it, I'm sure you can discover that that is true. Alright, so here's what I want us to do. Find the slope of the tangent line at x equals 0, x equals 1, and x equals 3. Alright, so as we discussed before, the derivative is a formula for finding the slope. So to find the slope at x equals 0, all we need to do is substitute in 0 into the derivative. So our derivative is up here, 2 minus 2x. Substitute in 0. 2 minus 2 times 0, that's 2. At x equals 1, the slope, I hope you're familiar with this notation of using m for the slope. That's going to be f prime of 1. So that's 2 minus 2 times 1, which is 2 minus 2, or 0. And at x equals 3, the slope is f prime of 3, which is 2 minus 2 times 3, which is negative 4. Notice that we found the derivative first, and then we substituted in the values of x. If you mix up the order and substitute the values of n and then find the derivative, you'll get the wrong answer probably. So remember that you find the derivative and then you substitute the values of x in to get the derivative. All right, so I want us to look at the graph of our function and how these tangent lines fit in with it. So what we should be getting is at the point on the graph where x equals 0, we should be getting a line of slope 2. At the point on the graph where x equals 1, that's up at the very top, we should be getting a line of slope 0, and at x equals 3, at the point where x equals 3, we should be getting a line where the slope is negative 4, and these are all tangent lines. So I'll show you a picture, and I believe you'll see that's exactly what we got. Now, by a tangent line, if I ask you to draw a tangent line or to approximate what a tangent line looks like, let's say I gave you a graph that looked like this, and I ask you to draw a tangent line right there. Well, what you want is a line that passes through this point that has the same slope as the graph at that point, the same slope as the curve at that point. And not everyone's picture is going to look different. Your picture will look a little bit different from mine. Even if we're both basically correct, they're not going to look exactly the same. So what you're looking for is a line that goes in, and this is where you have to do some approximation. Think about what the direction of the line is at that point, and I would say it's something kind of like that. And at this point, it might be something kind of like that. If you've got a curve like this, and you're at the very top, and then say at the top of a sort of like the top of a hill, then the direction, if you're at the very top, then the direction may be kind of horizontal like that. Let's do one more example using this function, and then we will go on to something else. Let's find the equation of the line tangent to f of x at x equals 3. Find the equation of the line tangent f of x at x equals 3. So we need to find the equation of a line. Well, I would suggest that we work with y minus y1 equals m times x minus x1. So what we need is, this is the point slope form of the equation of a line. We need the slope and we need the coordinates of a point on the line. Well, the slope we've already determined from right here. The slope is -4. Now, the x1 and y1, those are the coordinates of a point on the line. Well, I've already told you that I want that the x coordinate is supposed to be 3, so x1 is 3. The only thing that remains to be done is to find out what y1 is. Well, the point of tangency, the point where the tangent line touches the graph or intersects the graph at 3, that point is both on the curve and on the line. So my point is that that point is also on the curve. So if you know the x coordinate, you should be able to find the y coordinate by substituting the x coordinate into the function. So the y coordinate would be f of 3, which would be 2 times 3 minus 3 squared. That would be 6 minus 9, or -3. And so there's our equation of the tangent line. And you can rewrite that if you like. You could rewrite that as y plus 3 equals -4x. That would be plus 12, I think. Subtract 3 from each side, and you would get y equals -4x plus 9 if you want the equation solved for y.